In this video, we'll learn how to backfill data using piconfig. For a write-up, please check the link in the description. Backfilling data allows us to write data into the archives after the fact. Piconfig is just one method to do this. You can also use other methods, such as piufl, py2py, or pirdbms. Keep in mind that piconfig writes data to the Pi server very quickly. So if you have a lot of data to write, we highly recommend writing it to an offline Pi server. If you're still not sure what method to use, please contact tech support. The first thing we'll want to do is analyze what sort of data we need to backfill. We'll need to know how many points should be created, what the configuration of these tags should be, and also approximately how much data is going to be written in total. In our case, I've already created the points and configured them to collect data. You can also create fresh points which have no data in them. The advantage there would be that you can actually use the Pi server's compression algorithm in order to minimize disk space usage while still keeping the fidelity you choose in the compression settings. However, please keep in mind that if you do plan on using new tags, you need to make sure that no data is written to them, otherwise you will not be able to utilize the compression settings. In order to do this, you could either set the point source to some nonsense value, or set scan to 0. This will prevent new data from being written to those points. The next thing we'll want to do is take a look at the archives currently on the Pi server. In order to do this, you can use pisnap. Here we pull up a list of the archives, and we can see the start time and the end time for each one. If you're using a version of Pi server before 2012, you're also going to need to reprocess all of the archives that were created before the new points were generated. In this case, we only have one, but if you have multiple archives, you'll need to reprocess all of them. Now, whenever reprocessing archives, we highly recommend making a backup. So let's go ahead and do that. Here we navigate to the current backup directory and get it started. Now that we have a successful backup, we can go ahead and start reprocessing these archives. The first thing we want to do is unregister the archive. You can do this using pisnap. Remember, we're going to want to reprocess all of the archives with a start time before the points were created. When we reprocess the archive, records will be created for these new points. Once we can verify that the archive has been successfully unregistered, we can use the offline archive utility in order to start reprocessing. This utility is located in the bin directory. The syntax we'll use is piarc -input file, the path to the archive to be reprocessed, -output file, and the path to the file we'd like to create, the new archive. We'll also want to specify the duplicate flag, in case there are duplicate events. Now that we have a reprocessed archive, we can go ahead and register it. We can use pisnap in order to do this. Notice that this archive only goes back to December of 2011. If we take a look at the data that we wish to backfill, we see that it actually extends back to August of 2011. This means that we need to create another archive in order to hold that older data. Again, we can use smt to do this. Here we create an archive with a fixed start and end date, setting the start time to the oldest data point we wish to backfill, and the end time to the start time of the oldest archive, such that there are no gaps between the archives. And we'd like to make this a dynamic archive. Earlier in the video, we mentioned that you could use empty points in order to take advantage of the Pi server's compression algorithm. If you did decide to create these empty points, and you would like to take advantage of the compression, and you're using a pre-2012 version of the Pi server, there's one more step that you will need to follow. Those points currently have point created as their status. We will need to remove this as the snapshot value if we intend to utilize the compression. In order to do this, we'll use a script. You can find this script in the write-up, but I have it here copied into a text file. This script will create a text file, snap-to-delete, and it will put this in ADM, the folder where piconfig is situated. In order to run the script, we'll navigate to the ADM directory, and into piconfig, we'll feed the script. Now we can verify that the snap-to-delete file has been created, and here are the new points, which have point created as a snapshot value. If I don't want to delete point created as a snapshot value in all of them, I could simply remove those points from the list. Once I'm satisfied, I can go to piconfig and run the following commands. Again, these can be found in the write-up. And if all goes well, we will have deleted point created from the snapshot of these points. Once we have done this, we'll be ready to start backfilling data. You'll notice that the file we're using is a CSV. Excel is a good tool to manipulate CSVs. Here you can edit the columns, then export into a CSV file. You'll also notice that the first 3 lines of this file contain piconfig commands. The third line indicates what the order of the values is. In this case, a tag, a time, and a value. Now we're ready to actually backfill the data. Now that we've configured the Pi archives, and we've confirmed that we have all of our data in the proper format, we can go ahead and use piconfig, again, to actually backfill the data. In this case, we're going to want to pipe our modified CSV into piconfig, and then let it run. Now that we've finished writing the data into the archives, we can go into Process Book and confirm that it's actually there. So if we zoom out, it looks like we've got it all back. Remember, whenever using piconfig, you have full access to the server, and you do want to test a small amount of data first, just to make sure you're getting the expected results.